final video that we're going to look at is a transformation of moving the sine or cosine curve vertically up and down, which is a vertical shift or vertical translation. What we're going to be doing is we're going to be moving the midline up or down. Up to this point, our graphs have always been centered on the x-axis. So what we're going to do is what this illustration is if we have y equals sine of x plus 1, we're simply going to move our center line or our midline up 1 unit. So it's a vertical translation up, but then our sine curve will still have the same pattern and still have the same period and so on. So part of what we're going to do is focus on the vertical translation. The other part is we're going to summarize all of this wrapped up into one. And so we're going to apply all 4 transformations in this last graph that we see. So we're going to start off with 6a. We're going to look at the period, the amplitude, frequency, phase shift, vertical shift for each function. So in this first equation that we see, the new part that is being added to it is that we're adding 1 to the end. This is a vertical translation or vertical shift up 1. Keep in mind, if they were to have written it like this, parenthesis plus 1, that means it's a phase shift, so we're going to move our graph 1 unit to the left. But make sure you keep in mind where the grouping symbols are and where they are not. In this case, they are not wrapped around the 1. So the reason I made a change in the graph as far as this red dashed line, this is now going to be called our midline. And the midline is the first thing that I'm always going to put on my graph. The midline tells us the center of our graph is called the sinusoidal axis, but we're going to shift it up 1 unit because of the plus 1. So there's a sequence of events that I go through in order to graph all these. The first thing I always do is I want to establish the midline. So the midline, in this case, is going to be at a positive 1. We're going to slide our entire graph up 1, so the equation of this line is y equals 1. The second thing that I have in this graph is we have an amplitude change, and the amplitude change is a 2. So that typically is the second thing I always look for. I'm going to see what the amplitude is, so that's going to give me the location of the maximum height and the minimum values of my graph. So I'm going to put those with some fancy dashed lines here. The lowest the graph can go, I'm going to put down here. And the highest can go, I'm going to put up here, and I'm going to place those a little bit more strategically so that they line up. This. So if the center line is at 1, as we stated, then what we're going to do with this amplitude is the amplitude says we can go up 2 units from the center line. So when this is y equals 1, we can go up 2 from there, which means we will eventually get to y equals 3 as our max, and we'll get far down as y equals, if we go down to, a negative 1. So now I've established the highest and lowest points of the graph, so I've got the boundary lines for the graph to be drawn. In this equation, the cosine of x is 1, so we got 1 times the cosine of x. Anytime it's 1, our period is 2 pi, so I know it's going to finish 1 for rotation in 2 pi units, and there is no period or phase shift in this problem. So cosine curves, as I start to think about graphing this, I know I'm going to start at the highest point in the graph, so I'm going to start at the y equals 3, the maximum. And in 2 pi units later, we're going to be at a maximum again, so I'm going to start putting in the units for the x-axis. And because it only has a period of 2 pi, I'm going to stop at 2 pi, put another maximum point. Our cosine curves, we have our lowest point halfway between the maximum points, and in between maximum and minimums, we have our zeros. So this is the graph of 1 full period of function 6a. Now, if they want us to go 2 periods, we just repeat this pattern. So they asked us to go 2 periods, so now I'm going to extend my x-axis. It's 2 pi. I got to finish it at 4 pi, and we're going to go by pi halves again, so we'll go 5 pi halves. And then 6 pi halves is 3 pi, 7 pi halves, and we'll repeat the same thing. We start at a maximum, 2 pi units we finish at a maximum, halfway between or at 3 pi we're at a minimum, halfway between maximum and minimums we're at a cosine value of 0. So there's our second period. Okay? So there's one that has a phase shift, one that has a vertical translation and an amplitude change, but nothing else. Okay, then we look at 6b. This one gets a little bit more complicated because it has all 4 things going on at once. It has an amplitude change for the 1/2. It has a period change because of the 1/4. We have a phase shift that's going to be occurring in here. It's not at pi halves as it looks here, but we have that, and we also have a vertical translation. So there are several things going on in this graph, and we're going to take care of all those. I'm just going to shut off that fan. Okay, continuing on here. One of the first things I always want to identify, as I mentioned in the previous example, is the first thing is I'm going to identify where the center line is going to be. Okay. I think I'm still live. I just wanted to minimize it. I was panicked there. I thought I stopped my recording. So, okay, first thing I want to do is I want to identify the center line or the midline. So number one, where is the midline? The midline is going to be at y equals -3. So I'm going to record that on here. Your graph's going to look very similar each time if we keep using the same principle, but we get our graph set up fairly easily then. Second thing I'm going to do is I'm going to figure out how far above and below that line it can go. So I'm going to use the amplitude. Now the amplitude always tells me how far above and below the axis of center line I can go, which is a half a unit. So we can go above y equals -3, a half a unit, which is going to put us at y equals -2.5. And we can go a half a unit below that, which means we can get as low as y equals -3.5. The amplitude is always just going to be added on or subtracted to your center line. So to keep it simple, get your center line on there, then always add on and subtract your amplitude. So add the amplitude and subtract the amplitude, and you'll have the highest and lowest places that your graph can go. Next thing I'm going to do, I'm going to look for any phase shift. Now to get the phase shift, you've seen me work this transformation before. I want to get this in a little bit different form. I want to get this so we got y equals 1/2 is sine, and in order to get this into a workable form that I like, I want that coefficient of x to be 1, which means I have to factor out the 1/4. If we factor out a 1/4, we're dividing by 1/4, which means we're multiplying by 4, so that 4 times a fourth is 1, minus, and if we multiply 4 pi halves times 4, we're going to end up with, 2 will cancel, and we'll end up with 2 pi minus 3. Now, once I have it in this form, this is what I'm looking at as far as the phase shift. So the step number 3, the phase shift is the next thing I want to determine so I know where to start my graph. And the phase shift says, since it's a negative or minus 2 pi, remember it's counterintuitive, it's going to go 2 pi units to the right. So our graph is getting shoved 2 pi units to the right. And then from there, we're going to figure out what the period is. And then we're going to figure out how long our period has to be. So I want my start place, and then I want to know where I'm going to end it. So the period, since we have the value of b as 1/4, we've slowed down that Ferris wheel to 4 times the slowest speed. So it's 1/4 as fast as it used to be, which means our period gets 4 times longer. So our period should be 8 pi. Again, you can always take 2 pi divided by a value of b, which should be 8 pi as well. So let's start placing some information on here. First thing I want to do is figure out what would be a decent horizontal axis labeling. I think since we got such a large period, I'm going to go by values of pi. So the first one's going to be pi, 2 pi, 3 pi, 4, 5, 6, 7, and 8. So I'm going to go out to 8 pi, and that means I can get one full period of 8 pi, and you're going to see how I'm going to have to tweak that a little bit more as well. Our phase shift. Our phase shift says we want to slide our graph 2 pi units to the right. So, okay, we've got a sine curve. Sine curves normally start on the center line at 0. But because of the phase shift, it has forced us to slide at this point 2 pi units to the right. So our graph will begin here. So that's where I use that phase shift in step number 3. Then I jump down to step number 4, and I know that the period has to be 8 pi units long. And this is where I'm going to do a little doctoring of this, because I'm only at 8 pi, so if I got to get out there to 10 pi, I'm going to have to get a 9 pi in here and a 10 pi. So 9 pi, 10 pi. Okay, so since those others are in boxes, I'll just put those in a box. So one full period of this should go 8 pi units long, so by 8 pi I should be back to the center line. Sine curves halfway in between one full rotation, they're at their center line, so 1, 2, 3, 4. At 6 pi, we should be back down there, so that should be 1, 2, 3, 4, right in the middle. Halfway between zeros, it's at its maximum minimum. We already know the maximum value is at -2.5, so 1, 2, go up to 2.5, -2.5. In between zeros, it's got to be at its minimum, so go 1, 2, go down to a -3.5. And this is what our graph looks like. We have the amplitude taken care of, we have the midline taken care of, phase shift, and the period change. Right? And then what we want to do is I want to bring it back, and I want to come back to the x-axis, or to the y-axis, and I'd like to see where would this cross. Well, we know we got to go 1, 2 units, or 2 pi units to go back to our lowest point. So by the time we go back 2 pi units, or when our value of theta is 0, we should be at negative 3.5. So there's putting all the pieces of the puzzle together. They broke them up into small pieces, but once you get all 4 components in place, do them in this order. Get the midline located, figure out your amplitude so you know the highest points and the lowest points your graph will go. Third thing is make sure you know where your phase shift is going to be, so you know where to put your initial point. Once you know where your initial point is, go out there 1 full period long. So I'm going to go out there to 8 pi or 10 pi, so I can get the period of 8 pi in there, and then I'm going to start graphing the rest of the idea in there. So should be pretty manageable. We've taken it piece by piece, and now I put it all together. Hopefully that all makes sense to you.